Assalamu alaikum. My name is Zaim Ahmed, and today our topic is process scheduling algorithms. Before coming towards the main topic, first we have to discuss about a process in an operating system. In an operating system, a process refers to a program that is currently being executed into a system. So a process can be thought of as a container for a set of instructions or code that is being executed by the operating system. When a program is executed, a process is created which contains the information about the execution of that program. Each process has its own memory resources, its own processors, its own resources, and moreover, a process can also interact with other processes into the system. In addition to this, every process has its own unique ID and one or more threads for their execution. Moreover, a process can also have its child and parent processes that run parallel into the system. In addition to this, there is no restriction into the system that only one process can be executed into the system at only one time, but there can be multiple processes that will be executed into the system. When the multiple processes try to execute into the system, there is a problem arises that how to schedule these processes in such a way that all these processes get their resources perfectly and they complete their execution properly. For this, operating system is responsible to manage the resource allocation and also the execution of the processes that run into the system. This is known as the process scheduling. So process scheduling is mainly responsible for the execution of multiple processes in an operating system and also the resource allocation for these processes into an operating system. So the goal of the process scheduling is to maximize the system throughput and to minimize the response time and ensure fairness among the competing processes. In addition to this, the operating system can use the several algorithms to schedule these processes properly into the system. Such algorithms are known as the process scheduling algorithms. So I want to invite Ms. Mahanur to come and continue our discussion on this topic, process scheduling algorithms. And before coming towards the main algorithms, she she told you about the basic terms of the operating system and then coming towards the process scheduling algorithms.
Thank you, Zaim. So, before talking about these algorithms, we'll discuss some important terms that are frequently used in these algorithms. First one is PCB, that means process control block, which is a data structure containing essential information about a process needed by the CPU to execute that process, and it serves as the context of the process. Now the next term is ready queue, which is a simple queue of processes which wait for the allocation of CPU or the allocation of resources from the CPU. Next term is waiting time, that refers to the total time that a process spends while waiting in a ready queue until it gets the CPU or resources from the CPU for execution. Now what is burst time? The total time that a process takes in its execution is called burst time. Now how we will explain the completion time? So basically completion time is the time when a process enters a termination state. Now we will talk about the two major types of algorithms, preemptive and non-preemptive algorithms. So preemptive algorithms are those who allow a process to be interrupted or replaced by another process with a higher priority, while non-preemptive are those who don't allow a process to be interrupted once it starts. Now, moving towards process scheduling algorithms, first one is FCFS, means first comes, first serves. In this, processes are executed in the first come, first serve basis. It's a non-preemptive algorithms. Now, we will understand these algorithms by looking at this example. Here we have three processes in order P1, P2 and then P3. So firstly P1 will execute, then P2 will execute and then P3. As we can see, average waiting time in this example is 17 seconds. This algorithm has some advantages and disadvantages, like it's very easy to implement and it's very simple and user-friendly algorithm, while it's not ideal for time sharing systems as it has long waiting time. Now this second algorithm is round robin, which is a primitive algorithm. In this, each process is provided a fixed time to execute, that is called quantum. So when a process is executed for a given time period, it is preempted, and then the next process is executed for that given time, and so on. And another term in this algorithm is context switching, which is used by operating system to switch a process from one given state to another given state. Now we'll look at its example. Here we have three processes, P1, P2 and P3, and we set the quantum time to 4 seconds. So firstly P1 will execute for 4 seconds, then P2, and then P3 will execute for 4 seconds, and then again P1 will execute for 4 seconds. As you can see, P2 and P3 are already executed completely. So now P1 will continue to execute for its completion. As you can see, average waiting time in this example is 5.67 seconds, which is far better than the previous algorithm. And now as you can see, the burst time of the process P1 is 24 seconds, and for the P2 is 3 seconds, and for the P3 process is 3 seconds. So now we will look at these advantages and some disadvantages of this algorithm. This algorithm is very easy implementable and it does not depend on burst time. No priority scheduling is involved in this. While it has some disadvantages like it has no special priority to more important tasks, in this process don't have priorities, low slicing time reduces processor output, and it also spends more time on context switching. Now I would like to invite Mr. Zaim to explain further.
Thank you, Ms. Mahanur. As you have studied about the two basic process scheduling algorithms named FCFS algorithm and round robin algorithm. Now coming towards another process scheduling algorithm named shortest job first, short form SJF scheduling algorithm. This is a non-preemptive scheduling algorithm and the best approach to minimize the waiting time of all the processes into the system. In this process scheduling algorithm, we assign the burst times to all the processes that arrive into the system for their execution, and then the process which has the least burst time will be executed first, and then the process which have the much larger burst time will be executed later, and then the process which have the larger burst time and the process which have the largest burst time among all the processes will be executed at the end. So in this way, all the processes will be executed into the system successfully according to their burst times from their lower to the largest burst time. Now coming towards the example of the SJF scheduling algorithm to understand it more better in the better sense. Let's suppose that we have the four processes P1, P2, P3 and P4 that arrive into the system for their execution. Now we assign the burst times to these processes as 5, 4, 12 and 7 respectively. As you have known that according to the SJF scheduling algorithm, the process which has the least burst time will be executed first. So here the P2 is the process which has the least burst time. So P2 will be executed, and according to the burst time, it will be executed from 0 to 4 seconds. After this, the P1 has the least burst time among all the processes after the P2. So P1 will be executed after the P2 about 4 to 9 seconds. After this, P4 will be executed, and then the P3 will be executed at the end. In this way, all the processes will be executed successfully into the system according to their burst time from the lowest to the largest. So the waiting time and the completion time also given in here, and you can see the waiting time and the completion time of all these processes according to this algorithm, which is much better than as compared to the other algorithms. The average waiting time is 7.25 seconds. Now coming towards some advantages of the process of this process scheduling algorithm named SJF scheduling algorithms. So it is used for long-term scheduling and it reduces the average waiting time, and it is also necessary to predict it is also helpful for the batch type processing where the runtimes of all the processes are known in advance. Now coming towards some disadvantages of this algorithm. So it is necessary to know the job completion time beforehand, as it is hard to predict because the prediction of all the burst times of all the processes beforehand is a very difficult process. Moreover, it can cause extremely long turnaround times or starvation. So it can cause also the starvation, which decreases the performance of the system and also the efficiency of the system. Now let us move towards another process scheduling algorithm named priority based scheduling algorithm. It is also a non-preemptive scheduling algorithm and one of the most common scheduling algorithm in batch systems. In this process scheduling algorithm, we assign a priority to all the processes. We assign the different priorities to all the processes that arrive into the system for their execution. So according to this algorithm, the process which has the best priority, which has the maximum and highest priority, will be executed first. And after this, the process which has the least priority than the previous process will be executed later, and then all the processes will be executed in such a way that according to their priorities from the highest to the least. So let us move towards another example of the priority-based scheduling algorithm to understand it more better in a better sense. That suppose that we have the five processes P1, P2, P3, P4 and P5 that arrive into the system and for their execution. So the burst time of these processes are the 10, 1, 2, 1 and 5 seconds respectively, and the priorities are 3, 1, 4, 5 and 2 respectively. As you can see in this slide that the P2 is the process which has the highest priority. So according to this algorithm, the process which has the highest priority will be executed first. So P2 will be executed from the 0 to 1 seconds according to its burst time. After the P2, the P5 is the process which has the highest priority, which is 2, which is best among all the processes after P2. So P5 will be executed, and then the P1 will be executed, and then the P3 and then P4 will be executed into the system. In this way, all the processes will be executed successfully into the system according to their priorities from the highest to the least. After this, you can see the waiting time and the completion time of all these processes into the system according to this algorithm, and their average waiting time is 8.2 seconds. This is much better than other algorithms in this example. After this, there are some advantages of this algorithm is such that the processes with higher priority execute first, which saves time and it is better for the system performance, and it is very useful for the batch processing and also the batch systems, because this algorithm requires the priorities, and in the batch system we know the priorities of all the processes and we know the importance of all the processes into the system. And moreover moreover, this algorithm is customizable because the priority of a process can be adjusted based on its importance. Now coming towards some disadvantages of this algorithm. So in this algorithm, it can cause starvation, because this process can cause starvation if high priority process take too much CPU time. The low priority process can also be possible for an indefinite time. And then it is also the much difficult to determine the priority of the process, because we can determine the priority of the processes according to their memory allocation, according to the memory requirements, according to their time requirements, and according to the resource requirements. So this is a difficult task about their priorities, to determine these priorities of these processes. Now there is also cause a problem if two processes will have the same priority. So in this case, the two processes which have the same priority will be executed according to the FCFS, named first come first serve scheduling algorithm into the system. Now these are all the advantages and disadvantages of the priority based algorithm. So this is all our complete discussion about the process scheduling algorithms into an operating system. So we know about and we have studied about the FCFS scheduling algorithm, priority based algorithm, round robin, and also the SJF scheduling algorithm. So this is the whole discussion, and if you have any question, then please ask. So this is the complete discussion about this topic. So thank you.